Hi, in this video we're going to look at another topic on inequalities. This time we're going to look at graphing inequalities. It's a GCSE higher topic, and the things that you need to be able to understand before you start on this video. You need to be quite good at straight line graphs. You need to be reasonably good at plotting straight line graphs, recognizing what the equations of those graphs are, and similarly with quadratic graphs as well. You need to be able to plot them and understand what the shape of the curves mean, particularly the intercepts of the x-axis. What actually we're going to look at in this video is we're going to look at plotting and shading in a linear inequality. So this is an inequality of a straight line, and we're going to shade in a particular region. We're going to plot and shade a quadratic inequality as well, and finally we're going to look at a region that might be bounded by several different straight lines. Let's get a start and have a look at what we mean by graphing of an inequality then. Here we've got an equation which is x plus y is less than 4. So if we were to think about this in a slightly different way, if we assumed that it was x plus y equals 4, then this straight line graph over here would represent that. X plus y equals 4. And normally we'd do that with a nice solid straight line. Now the line that we've drawn on here is a dashed line. The reason for the dashed line is to say that it's actually an inequality. So the first thing we need to understand is that we're going to use a dashed line if it is less than something. Now thinking about this, it says x plus y is less than 4. What we're going to do is shade in all the area of where x plus y is less than 4. Now the easiest way to do this is to pick a test point. So on my axes here, I'm going to pick the point 1, 2, somewhere here, 1, 2, and I'm going to say to myself, if my x value, x, y, remember, if my x value plus my y value is less than 4, then that's in the region that I'm interested in. So let's do that. 1 plus 2 is 3. 3 is less than 4. So the area that I'm thinking of shading in is everywhere below this line. Okay, so this is x plus y is less than 4. Everywhere below the line, or to the left of the line, is less than 4. If it had been x plus y is less than or equal to 4, then we can do a solid line at that point. Okay, so this could have been a solid line here if it was x plus y is less than or equal to 4, but a dashed line shows it goes up to, but not including that line. What if it was the other way around? What if it was x plus y is greater than 4? Well, I hope it doesn't take a huge amount of extra thought for you to kind of realise that that must be all this area up here. So this would have been x plus y is greater than 4. And again, we can pick a test point anywhere in this area. So let's pick 4, 3. 4 plus 3 is 7. 7 is bigger than 4. So that's correct. This is the area that I'm interested in. Okay. Let's have a look at this in a slightly different way then. Here we have a number of different lines, and we need to write down what the inequalities are which satisfy the region R. So we can see there's an area that's been shaded in. Personally, I always go for the vertical and horizontal lines first because I think that they're the easiest ones. And let's look, we've got a vertical line down here, and it's everything above that line. So one of the inequalities is going to be everything above where y is 1. Now, the equation of this line, and this is why you need to be quite good at these, the equation of this line is in fact y is greater than, and it looks like it's a solid line, so we're going to say greater than or equal to 1. Okay, so everything here bigger than or equal to 1 is satisfied by R. Now, that also includes these areas over here, which I just don't want. I'm not interested in this bit up here. or this bit. So I'm going to have to think about what happens in terms of cutting these next two lines to minimise or to get rid of some of the area up here that's currently being satisfied, and that's why these next two equations are also going to be useful. Okay, let's have a look then. So let's look at the next line. Let's do this line that's going up here. Okay, so let's have a look at this line. This line, the equation of this line, well, it goes through the point 1, 1, it goes through 2, 2, 3, 3, 4, 4, and so on. This is the line y equals x. Now, y equals x is fine. However, it doesn't really help us when we're doing our inequality. I prefer to write it in the form of x plus y equals something, or x plus y is less than or equal to something. We can do it this way. It doesn't make any difference. In fact, I'll probably show you both ways. If I rearrange this in the form x plus or minus y equals something, I get x minus y equals 0. So that's another form of this. Now, if we were doing it the y equals x way, which is a way that you might have picked, let's pick a test point. Let's pick 2, 1. 2, 1 is down here. 2, 1 is in fact in the area that we're interested in. It's less than the line. It's in this kind of grey area. 2, 1. That's when x is 2, y is 1. So that means that I have to have the inequality sign going this way. So that would be that y is less than or equal to x, or if you prefer, x is greater than or equal to y. If I do it the other way, using this kind of format here, x minus y equals 0, then I will be looking at x minus y is less than 0. And let's just check that that works. Is greater than 0, sorry. Let's just see, let's pick my point again, 2, 1. So that's when x is 2, y is 1. This does satisfy it. This is a positive value, so that has to be greater than or equal to 0. So x minus y is greater than or equal to 0. Okay, so either of these two are correct for my second one. So I've now got two different inequalities. I've got the green line and the pink line that I've sorted. Finally, I've got the last one to do. The last one, again, let's colour that in a slightly different colour so we can see it. Let's do it in dark blue. So here it is. Here's my final line. We can see it crosses at 5 and 5. This is the line x plus y equals 5. So x plus y equals 5. Now, what we're interested in, all the values that are less than this. So I get this area here covered then. So x plus y is less than 5. So my third inequality is x plus y is less than or equal to 5. And again, it looks like a solid line, so I'm using the less than or equal to signs. Okay, so the three inequalities then for this, let's just tidy this up a little bit, are x plus y is less than or equal to 5. X minus y is greater than or equal to 0, or, if you prefer, x is greater than or equal to y, and the final one, y is greater than or equal to 1. That gives us our three equations. The three equations here show that the first one, y is greater than or equal to 1, gives us this area. The second equation, x minus y is greater than or equal to 0, gives us this area down here. And the final one, the x plus y is less than or equal to 5, gives us this area. Okay, so if we were to shade all those areas in, we can see the area that's mostly shaded by all three is the triangle that we were looking at before. This area here is covered by all three. The last one that I wanted to look at was a quadratic inequality, and this one, I've shown a quadratic curve here. I'll tell you what the equation of this line is. This is x squared, this is y equals x squared plus 4x minus 5. So this is the equation of this line. By factorising this, so if we set this equal to 0, so x squared plus 4x minus 5 equals 0, if we factorise it, we can see that we get x minus 1 and x plus 5 equals 0. That means that the roots of my equation are x equals 1 and x equals minus 5. And actually we can see that quite clearly here. Now with any quadratic it's always worth factorising because then we can find out what the roots are. The roots are particularly important when we are doing this type of work because we need to know what the areas are that we're interested in. So for example, let's say the question said x squared plus 4x minus 5 is greater than 0. Well, there are two places where it's greater than 0. It's greater than 0 all the way up here and all the way up here. So all this area and all this area is when it's greater than or equal to 0. So actually if it's greater than 0, so you end up with two areas like this, we can write our answer down in two ways. We can say that x is greater than 1 and x is less than minus 5. That shows this area here and this area across here. Now if it said x squared plus 4x minus 5 is less than 0, then the areas that it's less than 0 are all the areas down here. It's this bit of the curve here. So all the values that lie between minus 5 and 1 give this shaded region down here in pink. So the values we could say there are that x lies between 1 and minus 5. X, in fact, has got to be less than 1 and minus 5 is less than x. So this is if it's a greater than. If it's less than. If it's less than, it means it's lower than where the line is, lower than where the x-axis is. So we end up having this area here. It's kind of bounded by these 2 points. If it's greater than 0, then we end up with these areas coming up here. So that and that form the area, and all the values to the right of that and all the values to the left of minus 5 satisfy this region. So it's a little bit weird, the quadratic ones. You end up with two different kind of ways of writing the answer depending on what the question is. So if you end up with the ones that have got in two sections, leave your answer as two pieces. If you get the area below the x-axis that formed this kind of U shape here, then you can write it like this here. Okay, we're almost have a go yourself. Here I've shown a region that's been bounded by 3 lines. The 3 lines are here, here and here. I would like you to have a go at writing down what the inequalities are for these 3 regions that satisfy R here. Pause the video, have a go, and I will show you the answers in a second. Okay, so you'll see right at the bottom of the slide that it says one of the inequalities is x is less than or equal to 8. That's this one. This one is x is less than or equal to 8. Now that gives everything across here. So all the points to the left of this line are satisfied by x is less than or equal to 8. We're also interested in the points above this line. So here's another area. That gets rid of, effectively, this big block down here. So we're interested in everything bigger than when y is 2. So that must be that y is greater than or equal to 2. Right, okay, so that's 2 inequalities. I've got x is less than or equal to 8, y is greater than or equal to 2. Now the final inequality I've got is this slopey line coming up here, this diagonal line. Now, if we think about it, it goes through the following points. It goes through -2, and if you might actually go about it this way, you might be much happier doing y equals mx plus c. Okay, and actually I'm going to do that and then I'll rearrange it into a form that makes some more sense in a minute. So it crosses through -2, so I've got y equals something x minus 2. The gradient of this line, well, it goes 1 square along and 1 square up, so it's got a gradient of 1. So my equation is y equals x minus 2. Now, I want to put that in a slightly different form. I'd like it to be in the form x and y equal something. So what I'm going to do is rearrange it. I'm going to move my 2 to this side, so I'm going to add 2 to both sides. Let me just do this slightly differently. If I add 2 to both sides, then I get y plus 2 equals x. And if I minus y from both sides, I get 2 equals x minus y, or in fact, x minus y equals 2. So I've rearranged it. Now, I don't want it to be equal to 2, because that would just give me the line. What I'm interested in is when it's less than that. Okay, so when it's less than 2, all the areas down here, I think, are less than. Now, if I want to double check, I'm just going to pick a test point. So let's pick 6, 3. That's within the region. 6, 3. Is 6 minus 3 less than 2? No, it's not. Okay, so let's have a little think what's happened then. 6 minus 3 gives us 3. That's more than 2. Ooh, well, let's try again. Let's try another point. Let's try 7, 4. Well, 7, 4 is in the area, in the region. 7 minus 4 gives us 3 again. Well, that's not less than 2 either. So we must have made a mistake somewhere here. Now, let's pick a different point. Let's pick 5, 6, when x is 5 and y is 6. 5 minus 6 is minus 1, and that is in the region. Sorry, that's out of the region I'm interested in. So this can't be x minus y is less than 2. It's got to be x minus y is greater than 2. Let's pick one point on the line just to see. Let's pick 6, 4. 6, 4 is 6 minus 4 is in fact 2. So this has to be greater than or equal to. So the final answers that you were looking for are as follows, and I will do them up here. You've got x less than or equal to 8. You've got y greater than or equal to 2. And finally, x minus y greater than or equal to 2. Okay, hopefully you found this fairly challenging, to be honest. It's not an easy topic to do. Rearranging of these straight lines is fairly difficult. Hopefully you got the right answers, but if you didn't, what I suspect you did wrong was maybe looked at, as I did, this and decided it was the right answer. But just checking with a test point is really important, particularly in an exam. You will pick up marks throughout these questions. There will be lots of marks available. However, take your time, check it, and actually check it by putting some values in for your region. Okay, as ever within these videos, I've done some revision card notes at the end. When we are graphing inequalities, I want you to think about the following things. I want you to plot the equation as normal. I then want you to choose a test point, just like we've seen, to decide whether the test area is within the area that you're interested in, to get the inequality the right way round. Then you can shade the region that you are interested in. Okay, so this changes actually at A level, but right now we're actually just going to shade in the area that you want, so the region that's satisfied by the inequality. And finally, if you have a quadratic, then you may have more than one region to draw, so you might end up looking at this area down here, or these areas up here. Okay, hopefully this has been useful. Please check out the @TuptonMaths Twitter account. Subscribe to the channel for when new videos come out. As ever, good luck with your exams. Bye.